So these are the solutions and what points were taken off. So if you have any questions, I can go over them. So, I mean, I think the last one, I just thought maybe I'll explain the last one. So out here, you are doing a cross with the project you're doing a cross product with project, and you're looking for those rows where D number is equal to D number 2. So that would be, and project name is not equal to the other project name. So the first one doesn't work. So you have, so this is the one that works on this. So we have, and then for the next one, nothing works. And then on the last one, we have, so that's why it's 102. So if there's anything else, are there any other questions on the quiz?
I have a question about the first homework. I don't know if you want me to wait until the end of class and I can ask you, or
is it something that's very specific to yours, or is it what do you think that will be useful to everyone?
It's pretty. I just got 2 points off each question, but there was yeah. So there's no explanation. So I'm like, I must have done something wrong on each question.
Yeah, so you should speak to Shi Hong about that, because she grades the assignment, and if it's the same thing, you know, if the same, you're getting points taken off on every question for the same mistake, then just let me know. I'll speak to Shi Hong, because usually I'll take off points on one, and if it's the same mistake going down, I don't take off points on the other problems. So you should first check with her, and then if it's the same thing on all of them, I'll speak to Shi Hong, but you have to let me know.
Okay. I'll talk to her.
Anything on the quiz? So assignments, you know, speak to Shi Hong, and if it doesn't get sorted, speak to me after that. Or you can CC both of us, but I have to speak to Shi Hong anyway about it, because she grades them all. Okay, so if you have no questions on the quiz, I'm going to continue with the lecture. Okay. So we were doing the outer join in the last class. So I picked up a smaller example because I wanted to show the cross product. And so the outer join is the only technique operator by which we can get fields, you know, where when you do a, you know, for example, when you have this particular query, list employees and departments managed, and you want to put null if an employee is not a manager, then the only way of doing that is using the outer join. So I did all these examples with the outer join. So today I'm going to do a couple of queries with the outer join, in addition to this one that I just showed. So let's look at the first query. Okay, so this query is just similar to the one I've been showing so far. You know, I just want to show that the one that, so the only thing is previously I was saying that put null otherwise. So this case so if you look at this query, I said list employee name and department managed and null otherwise. So here I'm not asking you to print out the null. All I want you to do is to print out the name of all the employees, whether they are managers or not managers. List names of all employees who are not managers. So all I want is John out here. So you can, so this particular query you can do without using outer join. You can do this using difference. So we I'm sure we've done this query earlier in class, but I just wanted to just show the same query using difference and also the outer join. So let me just draw, if you did it using difference, it would be, and we've done this earlier. Okay, so this is without using an outer join. And if you wrote down this query, it would be so without an outer join, you can do the same query using a difference and the join. But you can do the same query using the outer join. It's a lot simpler using the outer join. So this would be, okay, so here, let me just, for now, let me just write it's equal to null. Okay, so here, instead of using the difference and the join, I can just do E outer join, left outer join with department, and the equality condition is manager is equal to social security number. So the thing is, out here, you have to show, so you want to select all the employees who are not managers. So in that case, the D name would be equal to null. So that's how you would do this query using the outer join. So I just want to say I wrote down out here D name is equal to null, but really whenever you use null, remember I said that null was kind of different from other values. So actually you don't write it as D name is equal to null. That this is not the way to do it. Um, you would have to write this down as D name is null. Okay, so when it's null, you have to write either your D name is null or D name is not null. So that's how you do it with null. Are there any questions? Did you understand this query? So this next query is very similar to this previous query, but I just want you to try this out with the outer join. So list first name of employees who do not work on any project. So I would like you to try out this query using outer join, because you can do this also with the difference. So in case you need the database, I put it on the left. Oh, and in case you miss any lecture, I am recording everything and putting it up on YouTube, and I've posted that on the announcements. So if you miss a lecture, you can watch it on YouTube, or you can, if all you want to see are the lecture notes, they are uploaded on my courses. Okay, so if you've written something a bit different from this, just let me know. Otherwise, I mean, this is the way of doing it. Okay, so if you got this correctly, just try this next one. Okay, list first name of employees who are not supervisors. So it's very similar to what we've been doing so far, but now you are doing an outer join on the same table, employee table. Okay, so here just you have to rename because otherwise you can't differentiate between the two. But other than that, it's just like the previous queries. So if you have done something differently, just let me know, because I mean, you have to do it. If you're doing it with an outer join, it has to be, um, somewhat like this. So, so any questions? Do you think you've sort of understood the outer join? So the only downside with the outer join is that on the relational algebra tool that you've been using, they don't have the outer join operator. So you won't be able to kind of test this out using the tool. That's the only downside. So any questions at all on relational algebra? Because this was the last operator I wanted to do on relational algebra. So I'm going to be moving on to SQL next. So anything at all, any questions? Okay, so I hope everyone's understood it and you're able to do this next assignment. So I'm going to move on to SQL. So we're done with relational algebra. So we have, so SQL is on chapter 6. It's 6 points. So right now I'm doing 6.1 and 6.3 from the new edition. And if you have the old edition, it's 4.1 and 4.3. And I have PowerPoint slides of these. So whenever I remember, I'll upload these slides on my courses. So SQL stands for Structured Query Language. And it is, it's a declarative language. So you don't have to write down how to do a query. I mean, like when you write a program, if you want to list something, you have to write down every single step in the program, otherwise it won't run. So unlike that, in SQL, you just have to say what you want done. You don't have to explain how to do it. So it's a declarative language. It's what you want. And one of the things I mentioned earlier, I think maybe one of the earlier classes, is that even if you write down a query in a not so efficient manner, you don't have to worry on the lower end. It will be done efficiently for you because there are query optimizers. So because of that, even if you don't write something that's that efficient on the outer end, it will be done efficiently on the in the lower end. So SQL is based on relational algebra, which is why I did relational algebra first. So I'm not very sure why in the textbook relational algebra comes after SQL, because given that SQL is entirely based on relational algebra, it seems kind of weird that they have put it down later. So SQL is interactive. It can be web-based. You can embed it in programs. So it's very flexible. So either you can do it on the command line. You can embed in programs. You can access it. It's web-based. So it's very flexible. You can use it in different manner. And there are different types of SQL commands. So we have, and I'll be doing all of them in class. So we have DDL, we have DML, and you have the rest of the commands. So DDL is data definition language. I might have mentioned this earlier. Data definition language. So these are commands like create table, if you want to delete a table, drop table. So all the statements by which you create the database schema is all comes under the data definition language. Then you have DML, which is a data manipulation language, and that's where you write all your queries. And so those are things like select, insert, delete, update. And then you have other commands, and these are how you create indexes, then how you create constraints. So I'll be doing all of these in this class. And then finally, with SQL, so relational algebra, I said, was set-based. So if you have duplicate rows, they get deleted because SQL, because relational algebra is entirely sets. Now SQL is multi-sets. So you could have duplicate rows, tuples. So. So you would have to remove the identical rows if you get identical rows. So I'm going to start up with the DML. So I'm going to start with this, and then I'll move on to the rest. So I'm going to start with how to write queries in SQL. So I'm going to start with this select statement, which is the most basic of the SQL queries. So let's do the syntax of select. So we have select from and where. Okay, so select, and then you have to write down the attributes you want to select. So select A1, A2, AN from the relations R1, R2, and so on to RM. And where are the conditions that you want to use? So on what conditions do you select? So this is the basic select statement. So the A1, A2, and AN, these are the output attributes that you want to select. There's R1, R2, and so on. These are the input tables that you're going to select the attributes from. And then conditions are the sigma or pi conditions. So this, if you map this to relational algebra, the mapping would be, so this output attributes is the pi, the project where you are selecting the columns you want to project. The input tables, this one would be, so this would be, you're doing a cross product. And the conditions out here, these are the, either when you do the sigma or you do the join condition. So, so that's what each part of the select statement means. So if I wrote the same thing down in relational algebra, this is the way it would be written in relational algebra. So this would be pi A1, A2, AN. And then you're doing either the sigma or the join conditions. And you'll be doing it on the tables R1, So that's the translation of the select statement. Okay, so let me do a few simple queries. So it'll, you'll figure it out at that point if you haven't already, because it is kind of very easy. So first, let's look at the first query. So we have list the birthday of employee named John. Okay, so if you did this in relational algebra, this is going to be pi birth date sigma. Okay, so this is the relational algebra query. So writing the same query in SQL, it's going to be select birth date from employee where first name is equal to John. So this is the pi, the R1, and this is the sigma condition. Okay, so do you understand? Does anyone have any questions on this? It is, a lot much easier to kind of write it because you don't have to use all those, those math symbols, pi, sigma. So it's actually, it's very English-like, so it's very clear from it. So let's look at this next query. List names of employees who work in research. So you want to list the names of employees who work in the department called research. Okay, so if I did this in so let me first write down the relational algebra query on this, and then you should write it down in. So this would be pi first name sigma is equal to research, and the number is equal to DNO. So this is the relational algebra query. So I would like you to try writing down the SQL query for this. Okay, so if you did something a bit different, just let me know. So we have this, the pi, this is the cross product. So this is the sigma condition, and this is the join condition. So I just wanted to show how it translates to the relational algebra. Um, and again, the order does not matter. If you wrote the join condition first and you wrote the sigma condition later, it doesn't matter. Whichever way you write it, it's fine. Okay, so if you don't have any other questions, let's try this next query. So for every project in Stafford list, P number, D number, manager name. Okay, so I would like to try this out. I'll pull up the company database too, so you can see both. So see if you can write down this query in SQL. So I hope everyone did this correctly. So again, this is the sigma condition, and this is the department join project condition. And this one is the employee join department condition. Okay, so so it is. I mean, there really nothing much to explain. It really is. You know, you just have to write down what you want done, and it does it for you. And you don't have to worry about ordering, because sometimes students are not sure whether these have to be written in a particular order. It doesn't matter in what order you write it. You just have to make sure you write all the join conditions together, because if you don't write down these join conditions, then if you remember correctly, remember it's a cross product, then you'll get a whole bunch of rows coming out together. So you just have to remember to write down the join conditions. That's the main thing, because otherwise when you connect um, one table with this table, there's no way of connecting them. So it'll be a cross product if you don't write down the join condition. So let me just do a few other queries, and each of these queries I'm going to show some feature that you haven't seen before. So let's look at this next query. So I'm going to have to remove this on the left because I don't need this anymore. Okay, so this next query is list names of dependents along with dependents birth date and employee's birth date. Okay, so out here, I want to list attributes that have the same attribute name in the company, in the employee database table. Birth date is spelled birth date, and it's the same name in the dependents table. So I want to list two attributes that have exactly the same name. So in this case, if you just wrote down, so here, if I wrote down the response has select dependent name, and I wrote down birth date and birth date. If I wrote the query down like this, so from employee dependent, so this is the join condition. Okay, so if I wrote down the query like this, you will get an error. It's going to flag the error. The error you're going to get is going to be ambiguous. Oh. Attribute name. So you are going to get this error if you do not, you have to somehow differentiate between them. So in relational algebra, we rename things. So here, what you can do is you can rename, but there are many ways of doing this. So let me just show you the easiest way of doing it. Would be just write down dependent dot birth date and employee dot birth date. So you just put the table name first. Okay, so that's how you deal with attributes that have identical names. Then suppose you are listing things from the same table, like, suppose I'm doing employee join employee. We've had many queries like that. So here, how would you do it? So let's look at this next query. List name of employee and name of her supervisor. So you want to list the name of the employee and the name of supervisor. It could be his or her. So let's just make it name of supervisor. So we have F name and F name out here. So what you do is, so when you do is you write from, you can write employee as E. So then you can write out here, select E dot first name, S dot first name, where E dot super SSN is equal to S dot SSN. Okay, so you can just, so then you can differentiate between the tables. You can just rename tables using this. If you wanted to drop the employee as E, you could instead, you could also write it down as, you could have written this down as, you could have also written from emp E MS. So you don't even have to write, as E. You can just write emp E and emp S and it'll do it. So, and this is the join condition. So then let me see what else. Yeah, let me just do a few others that just show you different ways of doing it. So next query. If you have any questions, just jump in. I'm going to just assume that you have no questions. List social security number of all employees. So this is the query where you would just write pi SSN emp. So this one in relational algebra would be, relational in SQL would be select SSN. So you don't have to specify, have a where condition. So this is the case where you have an unspecified where. You don't have to always use that. You can have another query. So this is a case where you are doing employee cross product department. There's no join condition. So it'll just list all the tables. If you want to list all the attributes, you would do that using so this will just do all attributes. And again, remember I mentioned that in SQL, it does, it will not remove duplicate rows. So let's look at this next query. If you want to remove duplicate rows, and let me show you in the next query. So if I list the salary, all the salaries of employees, I just want to list salary, you can write select, and without duplicates, you want to remove, then you say select distinct, and then salary. So By using this word distinct, it'll remove all the duplicates. Okay, so I'm trying to see. So, oh, and I do want to mention that I have uploaded, there is lab 2, and I've uploaded the instructions. So lab 2 gives you the instructions on how to start up SQL. And I've also uploaded company.sql and a large company.sql. So you can download those databases. So there's one so there's one thing to note is that the department, the support, they don't allow students to use MySQL on Agate. They say that it's a security risk. I'm not exactly sure why, but they are too scared to allow students access on MySQL on Agate. So because of that, every student in this class has an account on Basalt. So that's the name of the machine. It's called Basalt. So everyone has an account on Basalt. So the instructions on how to access your Basalt account is there in lab 2. So the password and username and everything is given in lab 2. So, once you get into Basalt, you can use MySQL on Basalt. It's a bit of a pain because Basalt does not have any web access, so you can't download or upload, which is why they have allowed, they're not allowing it on Agate. Because they don't want web access through the database. So it's a bit of a pain, but because they are so concerned about security risk, and Agate is to it would be awful because all student accounts are on Agate, so they consider it too much of a security risk. So it's all on Basalt, so it's a bit of a pain. You will have to log into Basalt, and then because there's no web access, you have to download things on Agate and then copy it onto Basalt. But I've given you all the instructions in lab 2, so take a look at it. And if you find, if you want to work from home on your laptop, just use SQLite. That's the MySQL and SQLite and all are all very similar. So if you could, but the thing is, when you do your assignments, make sure that they run on Basalt, because that's where we're going to check it from, because there are big differences between SQLite and MySQL. So as long as you make sure that your assignment will run on Basalt, that's all that matters. So yeah. So anyway, so let me just do another query in. So list all employees in department 5 who earn greater than or equal to 30,000 and less than or equal to 50,000. So here you can select star. So salary between 30,000 and 50,000. And D number is equal to 5. So you can, so I just wanted to just show different features that are there in SQL. So it's almost time anyway, it's 10 o'clock. So do any questions at all? Because I'm going to, I'll continue